eigenvectors. Eigenvalues and eigenvectors. This is our topic today. And let us define what is the meaning of an eigenvalue. Suppose we have a square matrix A of order n. Of order n mean n by n matrix is there over a field F. Field is F. Then a scalar lambda belonging to the field is called an eigenvalue of this matrix A if and only if there exists, this is the symbol of there exists, a non-zero n by 1 column matrix X which have elements x1, x2, so on, xn, such that this will satisfy this equation ax is equal to lambda x. So the non-zero column matrix X, this one, this is said to be eigenvector of the matrix A. This is square matrix A corresponding to the eigenvalue lambda. So this is the meaning of eigenvalue or definition. मीनिंग ये है कि A कोई स्क्वायर मैट्रिक्स है n by n, n रोज n कॉलम, लैम्डा कोई स्केलर है ओवर द फील्ड F. इसके कॉरस्पॉन्डिंगली अगर कोई ऐसा कॉलम मैट्रिक्स एग्जिस्ट करता है, कॉलम मैट्रिक्स मतलब जिसमें रोज तो n नहीं है, 1 2 n, बट कॉलम एक है, सो दैट इज व्हाई इट इज सेड टू बी ए कॉलम मैट्रिक्स. कोई ऐसा कॉलम मैट्रिक्स X एग्जिस्ट करता है जो इस इक्वेशन को सेटिस्फाई करता है, ax is equal to lambda x. It can also be written like this: a minus lambda I into x is equal to null matrix. So अगर that is why it is said to be an equation. अगर कोई x मैट्रिक्स इस इक्वेशन को सेटिस्फाई करता है तो हम कहेंगे कि x is the eigenvector of the square matrix A corresponding to the eigenvalue lambda. So this is the meaning of eigenvalue and eigenvector. Eigenvalue को हम लोग characteristic value भी बोलते हैं. This is the other name of eigenvalue. Latent root भी बोलते हैं. This is also said to be a latent root. Spectral value भी कहते हैं. Spectral value, latent root, characteristic value और proper value. ये सारे के सारे नेम जो हैं इसी के हैं. So this is the meaning of eigenvalue. And one more property related to eigenvalue is there. This is the property we have. Property is prove that the system of eigenvectors, those system of eigenvectors जो होते हैं x1, x2, so on, xm, corresponding to the distinct eigenvalues lambda 1, lambda 2, lambda m, means to say that हर एक आइगन वैल्यूज के कॉरेस्पॉन्डिंगली हर एक इगन वेक्टर होएगा. लैम्डा 1 के कॉरेस्पॉन्डिंगली x1, लैम्डा 2 के कॉरेस्पॉन्डिंगली x2 एंड लैम्डा m के कॉरेस्पॉन्डिंगली xm ऑफ द स्क्वायर मैट्रिक्स A. A इज ए स्क्वायर मैट्रिक्स, तो m डिस्टिंक्ट इगन वैल्यूज हैं और उनके कॉरेस्पॉन्डिंगली m वेक्टर्स भी हैं. एंड वी हैव टू प्रूव दैट, or we have the property that these eigenvectors are linearly independent. वो हमेशा linearly independent रहते हैं. Always remember, this is the property we have. We have also another property that the characteristic root or characteristic values or eigenvalues of a Hermitian matrix are always real. Remember that. Characteristic values or eigenvalues, because characteristic value और eigenvalue दोनों का मीनिंग सेम है. So the characteristic values और eigenvalues और characteristic roots भी हम लोग क्या देते हैं of a Hermitian matrix are always real. ये प्रॉपर्टी आप लोग अपने माइंड में याद रखेंगे. And one more property is there. Characteristic root of a real symmetric matrix are real. Characteristic roots of a real symmetric matrix A are all real. Characteristic root किसी real symmetric matrix के real ही होते हैं. ये भी एक प्रॉपर्टी है जो आप लोग याद रखेंगे. एक और हमारे पास है, at least one eigenvalue of every singular matrix is zero. At least one eigenvalue or latent root or spectral value or characteristic root, all are same. So at least one eigenvalue of singular matrix is zero. Remember this property. And one more we have, a square matrix is A is a square matrix and its transpose is A transpose, have the same set of eigenvalues. Same eigenvalues होंगी. Remember that. अगर हम कोई A मैट्रिक्स है उसकी eigenvalues फाइंड करें और अगर हम उसका ट्रांसपोज लें A का फिर उसकी eigenvalues फाइंड करें तो वो eigenvalues हमेशा सेम होंगे. Remember that. So these are some of the few properties which we have to remember. Let us come to the main part of the topic, that how to find out the eigenvalues. Let us check. It is very easy. Suppose we have a question. Find the eigenvalues and corresponding eigenvectors of this square matrix 1, 4, 3, 2. This is a 2 by 2 matrix. So you just need to find out the eigenvalues. For finding out the eigenvalues, we must know what is the meaning of I. I is identity matrix in which diagonal element is 1. Therefore, from this we need to find out this A minus lambda I. So A minus lambda I mean the matrix A is there, and lambda I mean this is lambda 0, 0, lambda. मल्टीप्लाई कर देंगे I मैट्रिक्स को लैम्डा के साथ और दोनों का सब्ट्रैक्शन करेंगे दोनों मैट्रिसेस का. So it come out to 1 minus lambda 4, 3, 2 minus lambda. Therefore, for finding out the characteristic values or characteristic roots of matrix A is कैसे आएगा? A minus lambda I determinant is equal to 0. By taking this determinant is equal to 0. So its determinant can be taken 1 minus lambda 4, 3, 2 minus lambda determinant is equal to 0. Now you can expand this determinant and it can be 1 minus lambda 2 minus lambda minus 12 is equal to 0. Open this equation. So you will get that it come out to be lambda square minus 3 lambda and plus 2 minus 12 is equal to 0. lambda square minus 3 lambda minus 10 is equal to 0. Now you can find out the roots of this equation, and it can be written like this: lambda square plus 2 lambda minus 5 lambda minus 10 is equal to 0 after factorizing this equation in lambda. So lambda plus 2, this is it, lambda plus 2 is equal to 0. Now its roots come out to be lambda plus 2, lambda minus 5 is equal to 0. So therefore lambda is equal to minus 2 and 5. So these are the two roots of the equation. It means these are the eigenvalues. Are roots mean eigenvalues. Eigenvalues of given matrix A. So this is the way for finding out the eigenvalues. वे ये है a minus lambda I determinant equal to 0 लेकर के इसको expand कर देना. Now let us find out the eigenvectors. So first eigenvalue we are taking lambda is equal to minus 2. Let we are taking the eigenvector x, that is x1 x2, and which is not 0, non-zero vector we are taking corresponding to this, corresponding to eigenvalue lambda is equal to minus 2. So इसके कॉरेस्पॉन्डिंग है तो ये इसको सेटिस्फाई भी जरूर करेगा. इट मीन ax शुड बी इक्वल टू लैम्डा x. ये हमने शुरू में पढ़ा. जस्ट सी एट द स्टार्ट दिस वन, ax should be equal to lambda x always. So now use here the value of lambda. Lambda is equal to minus 2 in this case. So this means ax is equal to minus 2x we can use, and after taking this on this side, so a plus 2I into x should be 0 vector. This is a 0 vector, null vector. So put the value. What is a? A is 1 4 3 2 and plus 2 into I 1 0 0 1 into x is equal to null vector. What it come out to be, इसको हम लोग थोड़ा सॉल्व कर लें तो ये हमारे पास आ जाता है 3 4 3 and 4 into x vector. X vector is this one, x1 x2, and this is a null vector 0 0 column vector. Now you can multiply these two matrices. This is 3x1 plus 4x2 is equal to 0. Similarly, from the second equation, 3x1 plus 4x2 is equal to 0. दोनों same equation है. और हमें क्या चाहिए? What we need, we have two unknowns, x1 and x2. So finding out the value of x1 and x2, we must have two equations. But here there is only one equation. So अब हम इसी से ही करेंगे. 3x1 is equal to minus 4x2 can be written like this. So x1 upon 4 and x2 upon minus 3. ये उसके डिनोमिनेटर में चला जाएगा और ये उसके डिनोमिनेटर में चला जाएगा. So these are the proportionate values of x1 and x2. x1 is proportionate to 4 and x2 is proportional to minus 3. So therefore the vector x is x1 x2 we have taken, this is 4 and minus 3, is the eigenvector corresponding to lambda is equal to minus 2. So this is the eigenvector corresponding to lambda is equal to minus 2. जितनी भी eigenvalue होंगी उतने ही eigenvectors होंगे. So for the second eigenvalue lambda is equal to 5, उसके लिए भी हमें eigenvector find करना पड़ेगा. तो जितने भी eigenvalues उतने ही eigenvector. So let y now and x ही चाहे ले लीजिए, वो कोई इशू नहीं है. लेट x इज इक्वल टू वैल्यूज उसके डिफरेंट कर दीजिए. पहले x1 x2 था, y1 y2 कर लीजिए. सो आप जानते हैं ax शुड बी इक्वल टू लैम्डा x, और you know that lambda is 5 in this case. So it come out to be a minus 5i into x is equal to null vector. So the value of a is 1, 4, 3, 2, and this is 5i, 5, 0, 0, 5, and taken with this we have x vector y1, y2 is equal to 0, 0. इसको भी वैसे ही सिंप्लीफाई करेंगे. So it come out to be minus 4, 4. This is 3, and this is 2 minus 5 is minus 3. So this is y1, y2 is equal to 0, 0. So from this we have minus 4y1 plus 4y2 is equal to 0. 3y1 minus 3y2 is equal to 0. दोनों को मिलाकर के एक ही चीज आती है, y1 is equal to y2. चेक कर लीजिए आप. So the proportionate values will be y1 over 1 and y2 over 1. So therefore the next eigenvector is 1, 1, corresponding to lambda is equal to 5. So this is the second eigenvector. eigenvector जनरली कॉलम में लिखा जाता है, बट अगर हमने इसको नॉर्मल फॉर्म में लिखना हो तो हमारे 1, 1 ट्रांसपोज. अब जो पहले हमारे पास आया है वो है हमारे पास 4 and minus 3 ट्रांसपोज. अब याद करिए लीनियरली इंडिपेंडेंट और लीनियरली डिपेंडेंट वाले टॉपिक में हम लोग ऐसे लिखते थे. So this is the procedure of writing down the eigenvectors. Remember. So this is the technique by which we can find out the characteristic equation, then solve the characteristic equation a minus lambda I determinant equal to 0 and find out the values of lambda. ये 2/2 का मैट्रिक्स था. अब हम एक लोग ऐसा क्वेश्चन लेते हैं जिसमें 3/3 का मैट्रिक्स है. So the matrix A is 1, 0, minus 1, 1, 2, 1, and 2, 2, 3. This is matrix A we have. So what we need to find out, A minus lambda I determinant should be 0. अब मैं सीधा कर रहा हूँ, आप इसको थोड़ा सिंप्लीफाई कर सकते हैं. So therefore this is the characteristic equation, and put the values 1 minus lambda 0 minus 1, 1, 2 minus lambda 1, 2, 2, 3 minus lambda is equal to 0. So characteristic equation को we can expand this characteristic equation 1 minus lambda, and it come out to be this into this minus this into this. So 2 minus lambda into 3 minus lambda minus 2. 0 से expand करेंगे तो वो 0 ही आएगा. And minus 1, this is 2 minus 2 into 2 minus lambda is equal to 0. Now simplify the equation. 1 minus lambda, this is a 6 minus 2 lambda minus 3 lambda, 5 lambda plus lambda square minus 2. This is a 2 minus 4 plus 2 lambda is equal to 0. Now you can simplify it, and this is a 6 minus 2 is a 4 minus 5 lambda plus lambda square, and this is a 2 lambda minus 2 is equal to 0. Now you can multiply this factor inside. So it is 4 minus 5 lambda plus lambda square minus 4 lambda plus 5 lambda square minus lambda cube minus 2 lambda plus 2 is equal to 0. So minus lambda cube, 5 lambda square plus lambda square, 6 lambda square 6 lambda square, and then we have minus 5 lambda, minus 4 lambda, minus 2 lambda, and that come out to be 11 lambda and negative, and then we have 4, and this is 2, that come out to be 6. So ultimately minus से multiply करके lambda cube minus 6 lambda square plus 11 lambda minus 6 is equal to 0. So this is the cubic equation in lambda we have. और हमें क्या चाहिए, हमें इसके 3 रूट चाहिए, क्योंकि क्यूबिक में है तो इसके 3 रूट्स आएंगे, 1 2 3, ये वैल्यूज नहीं रहेगी, 3 roots will be there. So 3 roots mainly named as lambda 1, lambda 2, lambda 3. So वो 3 वैल्यूज हमें चाहिए, और बिकॉज ये एक क्यूबिक इक्वेशन है तो पहला रूट हम लोग हिट एंड ट्रायल मेथड से फाइंड आउट करेंगे, और हिट एंड ट्रायल मतलब जो इसको सेटिस्फाई करे। सो सेटिस्फाई चेक करने के लिए तकनीक है कि हमें सबसे पहले 0 पुट करके देखना है। लैम्डा इज इक्वल टू 0 पुट करें तो 0 0 0 माइनस 6 इक्वल टू 0, वो सेटिस्फाई नहीं करता। लैम्डा इज इक्वल टू 1 पुट करेंगे तो पुट लैम्डा इज इक्वल टू 1 हियर, सो पुट करें 1 माइनस 6 प्लस 11 minus 6, and it come out to be 1 minus 6 plus 11 minus, yes, it is satisfied because it will give you 1 minus 6 plus 11 minus 6 equal to 0. So 0 is equal to 0, ये satisfy कर जाता है। इसका मतलब ये एक रूट है इसका। अगर 1 सेटिस्फाई ना करे फिर -1 चेक करना है पुट करके, अगर -1 ना करे फिर 2 करना है, फिर 2 के बाद -2, फिर 3, फिर 3 -3, 4 -4 एंड सो ऑन। ऐसे हिट एंड ट्रायल मेथड से ये चेक करते जाना है। और लैम्डा इक्वल टू 1 इज द रूट ऑफ दिस इक्वेशन, इसका मतलब लैम्डा इक्वल टू 1 सेटिस्फाई दिस इक्वेशन। सो बाकी के रूट फाइंड करने के लिए हमें रिमेनिंग क्वाड्रेटिक फैक्टर फाइंड करना पड़ेगा। उसके लिए हमारे पास ये टेक्निक है कि ये पहला रूट 1 आ गया, इक्वेशन के कोफिशिएंट लिखिए, इसका कोफिशिएंट है 1, इट्स कोफिशिएंट इज -6, इट इज 11, इट इज -6। अब देखिए 1 into 1 is 1, and what is the resultant, -6 plus 1 -5, इसका रिजल्टेंट 1 ही है। अब 1 into 5 is -5 is -5, so 11 minus 5 is 6, 1 is to 5 6 is 6, now its resultant is 0, वो करेगा ही करेगा क्योंकि वो उसका रूट है, it will give you 0, so the remaining roots will be given by this factor, so this is lambda square minus 5 lambda plus 6 is equal to 0, ये जो कोफिशिएंट है। सो द रिमेनिंग रूट्स फ्रॉम दिस आर, इसको फैक्टराइज कर लीजिए और बन जाएंगे 2 and 3। सो दीज आर द फैक्टर्स ऑफ दिस इक्वेशन। इस इक्वेशन के फैक्टर्स हैं लैम्डा -1, लैम्डा -2 एंड लैम्डा -3 इज इक्वल टू 0। मल्टीप्लाई करके चेक भी कर सकते हैं, यही इक्वेशन आएगा। So 3 eigenvalues are there. Eigenvalues are lambda equal to 1, 2, 3. Corresponding to these eigenvalues, we need to find out eigenvectors. So let the first eigenvector is x1, x2, x3. ये 3 का होएगा, 3 by 1, क्योंकि 3 by 3 का मैट्रिक्स था। ये नॉन जीरो eigenvector आपने लिया, and this is the eigenvector corresponding to eigenvalue lambda is equal to 1. Now therefore we can use the equation ax is equal to lambda x, use the values, and the matrix A is given to us 1 0 -1 1 2 1 2 2 3, and बिकॉज यहाँ से हम लोग ऐसे भी कर सकते हैं, इसको ऐसे दोबारा से लिख लें, लैम्डा की वैल्यू 1 है, so a minus I into x is null matrix and x matrix negative sign. This is 1 0 0 0 1 0 0 0 1. So we have the vector x, x1 x2 x3 is equal to the null vector is this. Now you can subtract these. This is 0 0 minus 1 and 1 1 1 2 2 2. So this is x1 x2 x3 is equal to 0 0 0 we have. So what it come out to be, तीनों इक्वेशंस आपके पास आ गई हैं. अब एक हम लोग इसको सिंप्लीफाई भी कर सकते हैं. सिंप्लीफाई करने के लिए हम रैंक मेथड भी यूज कर सकते हैं. रैंक मेथड मतलब रो ऑपरेशंस भी लगा सकते हैं. रो ऑपरेशंस के लिए क्योंकि सबसे पहले हमें टॉप मोस्ट एलिमेंट 1 चाहिए, तो अब R2 को R1 कर दीजिए. सो यू विल गेट 1 1 1 0 0 -1 2 2 2. This is x1 x2 x3 and this is 0 0 0 by the operation interchanging R1 with R2. R1 has been interchanged with R2. Now हम लोग subtract कर सकते हैं by using R3 as R3 minus 2 R1. R1 को pivot use करके 1 1 1 0 0 -1. लास्ट वाला रो सारे का सारा 0 बन जाएगा. So x1 x2 x3 this is 0 0 0. Now operate the equation. Now first equation will be x1 plus x2 plus x3 is equal to 0, and from the second row we can get minus x3 is equal to 0. So यहाँ से तो x3 equal to 0 आ जाता है. Use x3 0 here, so you will get x1 plus x2 is equal to 0. So it can be written x1 is equal to minus x2. So x1 over 1 and x2 over -1 is there. And therefore, and what is the value of x3? X3 is proportionate to 0. So it means we have 1 -1 0 is the eigenvector corresponding to lambda is equal to 1. Lambda is equal to 1 के लिए ये corresponding eigenvector है. Similarly, the other eigenvectors can also be obtained. For lambda is equal to 2, we have to use the same methodology, and let's take x as another value y1 y2 y3, which is a non-zero vector corresponding to lambda is equal to 2. So we should have ax is equal to lambda x and a minus 2I into x is equal to null vector, and 2I, you know that I vector is the identity matrix. So ऑपरेट करने के बाद हमारे पास आ जाता है, this is -1 0 1 1 0 1 2 2 1, and this is y1 y2 y3, and this is 0 0 0. Now you can simplify it. यहाँ 1 करने के लिए हम लोग R1 एंड R2 को इंटरचेंज कर देते हैं. 1 0 1 -1 0 1 2 2 1 y1 y2 y3. This is 0 0 0 by interchanging rows R1 and R2. Now we can use the operation, and using the operation R2 will be added up with R1. Sorry, यहाँ पर -1 है. Please change here. This is a -1. So by if we add R2 with R1, you will get first row same, second row will be 0, 0, 0, and the second operation will be operated on R3 as R3 minus 2 times R1. This is 0, this is 2, and this is -1, and this is y1, y2, y3 is equal to 0, 0, 0. Now the resultant equations can be written. Therefore, from first y1 plus y3 is equal to 0. Okay, y2 का coefficient 0 है. And from last, you will have 2y2 minus y3 is equal to 0. And from this equation, 2y2 is equal to y3. So this is we have, and what is this? This is from this, the value of y2 is y3 over 2. Use the value. y3 का value आप इसमें put करिए. y3 is equal to 2y2. So y1 plus 2y2 is equal to 0. And from this, y1 is equal to -2y2. And it can be written here, y1 over -2. And this is y2. And what is y2? y2 is y3 over 2. So it will be y3 over 2. So over 1 can be written. So this is the eigenvector we have -2, 1, 2 corresponding to lambda is equal to 2. So this vector can also be written as a column vector like this. -2, 1, 2 is the eigenvector corresponding to lambda is equal to 2. No. Now, for the last eigenvalue lambda is equal to 3, we shall have another eigenvector, that is z1, z2, z3. This is just a name of the values of the vector. So you can use ax is equal to lambda x. It will give you a minus 3I into x is equal to null vector. So this will give you -2, 0, -1, 1, -1, 1, 2, 2, 0. And this is Z1, Z2, Z3. And this is the 0, 0, 0. Now you can operate some row operations again, interchanging the second row with the first row. 1, -1, 1, -2, 0, -1, 2, 2, 0. And this is Z1, Z2, Z3. And this is 0, 0, 0. This is by operating the operation interchanging R1 with R2. Double arrow means interchanging. And the next operation which we can operate by using R2 as R2 plus 2R1 and R3 as R3 minus 2R1. R1 is used as a pivot. So Z1, Z2, Z3 will be as it is. This is 0, 0, 0 vector. And 1, -1, 1. This is 0. And this will be -2. And this will be 1, 0, 4, -2 is there. Now, just see the second row and the third row. Now, we can make the third row as 0. Just using the operation R3 as R3 plus 2R2. And the first row will be same. Second row will be same. Third row will be 0. by using this operation. So this is the resultant matrix we shall have. Now, just to simplify or multiply these two matrices, इस रो मैट्रिक्स को 3 by 3 मैट्रिक्स को इस कॉलम मैट्रिक्स से मल्टीप्लाई कर दीजिए और आपके पास इक्वेशन बन जाएगी Z1 minus Z2 plus Z3 is 0 and from second row minus 2Z2 plus Z3 is equal to 0. From this equation 2Z2 is Z3 or Z2 is Z3 over 2. Use the value of Z3 is equal to 2Z2 in this. So Z1 minus Z2 plus 2Z2 is 0. So Z1 plus Z2 is equal to 0. So Z1 is equal to minus Z2. So Z1 over 1 and Z2 over minus 1. And you just see इन दोनों को combined करके कर देंगे तो combining these two, so Z1 over 1, this is Z2, and the minus can be written here. Symmetry बनाने के लिए ये minus sign यहाँ लगेगी, यहाँ positive 1 लिखिए आप. This will be plus 1, so Z1 over minus 1, Z2 over 1, and Z3 over 2. So your eigenvector is, so therefore x is equal to minus 1, 1, 2 is the eigenvector corresponding to lambda is equal to 3 eigenvalue. So this is the last eigenvector corresponding to lambda is equal to 3. And one more thing. Now, the question arises, if you multiply in this, if you multiply with the minus 1, so you will get a 1 here, you will get a minus 1 here, you will get minus 2 here. So after multiplying, because there is the confusion that under which we have to take a negative 1, either with this or with this. So there is no confusion about that. अगर आप उसको मल्टीप्लाई भी कर देंगे माइनस से तो आपके पास इगन वेक्टर फिर ये बन जाएगा 1 minus 1 minus 2. सो इस इगन वेक्टर को अगर माइनस से मल्टीप्लाई कर दें तो ये आ जाता है. तो दोनों में कोई भी लिख सकते हैं, चाहे ये भी ले सकते हैं चाहे वो भी ले सकते हैं. सो बोथ आर करेक्ट. तो आप लोग कंफ्यूज नहीं होइएगा इसके बारे में. माइनस से मल्टीप्लाई करके यहीं पर आप ये भी ले सकते हैं और ये भी ले सकते हैं. So this is the conclusion of this, and I conclude my class here. Thank you very much. You can ask me your problem.